And here it is, the final installment in the divisibility series. And in this one, I'm going to be covering divisibility rules for numbers, I believe 31 through 47, which is all the primes, basically all the primes until 50. And so let's start with 31. 31. Subtract 3 times the last digit from the remaining number. So let's take 31 multiplied by 53. That's 1,643. So let's take 1,643 and test the number. So subtract 3 times the last digit. So that's 164 minus 9. That equals 155, and then 15 minus 15 equals 0. If you get 0, it's the same thing. That means it works. 0 means it's divisible. Then divisibility by 37. This is a little bit more difficult, and it uses a double-digit multiplier, actually. So what you do is subtract 11 times the last digit from the remaining number. And instead, double-digit multiplier for the means 11 multiplied by that remaining. And so let's do. Let's do 37 multiplied by 48 is 1,776. And so 11 times that last digit is 66. So that's 177. Minus 66, that equals 111, and 11 times that means 11 minus 11 equals 0. Again, 0 means that it works. So that one works as well. Test by 41, subtract 4 times the last digit from the remaining number, and let's do 41 multiplied by 52. Let's do 55. So that's 2,255. Nice number. Okay, so 2,255. What you do is multiply the last digit by 4, and then you subtract. So that's 225 minus 20 equals 205. And I actually know for a fact that's divisible because 41 times 5, so that works. 43. Now this gets quite annoying. So 43, the multiply is 13, and you may want to make a list of the 13 times tables on the side, but I don't know. It's not so hard to multiply by 13. Especially if you have a calculator on. Wait, no, if you have a calculator on, you can just test it with that. Anyway, these 3 videos are basically for if you don't have a calculator around. And so instead, let's do 43 multiplied by 43 times 54. That's 2,322. And let's take the last digit, which is 2, multiply it by 13, that's 26, that's 232 minus 26 equals 206. And then 13 times this equals, I think this is actually directly divisible, I believe, because it is, oh wait, did I mess up again? Yes, it's adding, I messed up again. Usually, if it's a smaller number, if it's a non-two-digit thing, then you're going to be subtracting and not adding. This one's a 2-digit one, so you're going to be adding. So let's see, 2,322. Take that last one, 232 plus 26 equals 258. Then 225 plus 13 times 8 equals 104 plus 104 equals 129, and then 12 plus 117. This isn't really helping, is it? It's 125, and then 12 plus 65. This would get very long. That's 77, and then okay, did I mess up again? Seriously? Yeah, I messed up. Okay, so let's do 3,182 instead. I don't know. I messed up on that last one. So then plus 26, that equals 344. And then plus 13 times 4 is 86. And that's 34 plus 52. And that's 86, which is 43 times 2. And so 3,182 is divisible. And then the final one, which is divisibility by 47. And this is quite annoying because the multiplier is 14. And most people cannot recognize multiples of 14 at sight. So again, make a little list of 14 times tables on the side if you're not quite sure of your 14 times tables. But we're going to use the same method. Subtract 14 times, this time subtracting, subtract 14 times the last digit from the remaining leading number. And if it's divisible by 47, then so is the first one. So let's do 47 times, let's do something smaller, 26, 1,222. So 1,222, you do 2 times 14 equals 28, and then 122 minus 28 equals 106. I mean, sorry, no, wait, okay, no. 94 equals 94, and then 94 is recognizably 47 multiplied by 2, so 47 works as well. I have put the link in the description of, I believe, the previous video, and I'm going to put it in this video as well. You should really check it out if you don't really get this video. So, that's all, basically, for this video.